Hello, today we're going to be talking about enzymes. If you remember from our organic compound notes, we learned that enzymes were a function of the protein. So now we're going to divulge into that a little bit more so we can learn a little bit more about it. An enzyme is a specialized protein that is going to lower the activation of energy required to make a reaction proceed. It's a catalyst, okay? And if you remember what the activation of energy is, it's the energy needed to get that reaction started. So do you see how it has crunched down? The enzyme will lower that so that the reaction can proceed, okay? And you can see here with the graph that when you have an enzyme added in, it will speed up the reaction because, again, the activation of energy is lower. Again, this is just another graph to demonstrate the effectiveness of an enzyme. Okay, so there are some things that are particular for enzymes. They are highly specific for the reactions that they engage in or catalyze. So for an example, there's an enzyme called lactase. Lactase will only break down lactose into glucose and galactose. So it will only break that down. Lactase will not break down maltose. Okay? Enzymes do speed up chemical reactions, okay, because they lower that energy of activation. They are reusable. They are reversible. Okay, so just to give you a little example here. Here is amylose, okay? And amylase, the enzyme, is breaking down amylose into maltoses. So each of these red molecules is a molecule of glucose. So amylase is breaking down amylose into maltoses. Very specific, and it will not be used up. Okay, this is called an enzyme substrate complex. This is when the enzyme and the substrate are going to bond together. And we do have some terms that will help identify that. I just want to point out a couple of features with enzymes. There are different things that are going to affect how well the enzyme activity will work. Temperature, salt concentration, pH are going to either speed up the reaction, slow it down, or make it held constant. So each enzyme reacts favorably within a certain range of temperature, salt concentration, and pH. And there are also some enzymes that require some help, or coenzymes they're called. And we'll talk a little bit about that when we talk about photosynthesis. Okay, so if we're using heat to speed up the reaction with an enzyme, all of a sudden our reaction might stop because the temperature has gone too high. Okay? Okay, so some terms that are important. We have the active site, which is called the binding site of the enzyme. We also have the substrate, which is what the enzyme is going to act upon or break down or make. So just to show you that, we have the active site there, okay? And then you can see here how they are going to join together, or they could break it down if it went in the reverse reaction. Also, there are some things that are called enzyme inhibitors, okay? And that will actually break or block enzyme action. And that would be something that would enter into the reaction, enter into the active site, and will not allow it to work. Okay, so two types. We have a competitive inhibitor and we have a non-competitive inhibitor. Okay, the competitive inhibitor actually will take the place of the substrate. The non-competitive inhibitor will actually change the shape, not allowing for binding to occur. Okay, there are two ways that enzymes work, or at least two hypotheses on how they work. The first is a lock and key, and the second is called induced fit. For the lock and key model, it's just like everyone has a particular key that will open up their particular house or their car door. Okay, so reactants are going to fit into the active site, very specific. Reaction will take place, product is released. Again, it's an exact fit. Okay, so we have our active site, substrate or sucrose is going to bond in. It will then start to break down into glucose and sucrose we're talking about. It's going to break down into glucose and fructose, and then they will break it apart. Very unique on the shape, okay, and it's a lock and key idea. The next way is called the induced fit model. Now, the induced fit model, we're going to have a little bit of a change in the shape. So once the reactants bind to the active site, there's a change that occurs, allowing the reaction to take place, releasing the product. Then the enzyme will go back in its original shape. Okay, and you can see here, once we have the substrate binding, there's a change of shape, we release the product, and it goes back to normal. If you have any questions at all, please see me tomorrow. Thanks. Have a great night.